So, good morning. I'm Sebastian. I'm a site reliability engineer at Uber, and I'm going to talk today a little bit about deploying quickly and reliably. A heads up that this is going to be about 50% technical and talking about what we do at Uber, and then about 50% talking about some of the things we've learned while doing this at Uber, so sort of reliability takeaways. In case you haven't heard of Uber, I know we're not in the news very often. Um, We are a transportation and logistics platform, and our mission is transportation as reliable as running water, everywhere for everyone. So, there was a talk last year at SRECon. It was by Michael Gorman, who is a production engineer at Facebook, and the talk was on continuous deployment. And he was specifically talking about how many times per day they push Instagram to production. And one of the things he did was he polled the room and he said how many people deploy X times a day, and had people put their hands up. And when I watched the talk, I thought about how this applies at Uber and how many times we push to production. And the answer is absolutely no idea. And I'm going to talk a little bit about why this is a tough question to answer, and sort of how we've sort of made gradual steps towards continuous deployment, and how we sort of differ from Instagram. So a quick history of Uber's sort of service architecture. When I joined in late 2014, we had the core functionality of our backend services was in monolith applications, so larger services. And so these services would be deployed through a very long and manual process, and there would be people actually babysitting a deploy to production. And I've sort of drawn the workflow up here of how we deployed one of the services, which was the dispatch service. And that handled everything required to take a trip. So here you can see we sort of deployed to a small city. Sorry, Santa Barbara for that one. Medium city. A few hours later, we went to a large city. And then we would actually let that bake overnight. And so the next day we would come in and deploy to these other groups of cities by the number of trips before we went global. So this was a really managed process to get into production. We would actually take a really deep look at the metrics constantly throughout the deploy, look at sentry errors. So it was a very managed deploy process. Unfortunately, it was incredibly slow. I was actually part of the team that pushed this thing into production, and when I was in engineering school, I didn't dream of watching dashboards and pushing a button in a UI. I wanted to do some other things. So one of the problems was we actually had people spending their time every week pushing this thing into prod. Obvious other drawbacks are we were on a weekly deployment schedule to get this thing into production. And so teams were really slowed down. The more and more people we hired, the worse the problem got. And if you've ever had a deployment schedule, you know that people love to sneak their commits in at the last minute. So watching the last talk about automatically debugging deployments, I was having a lot of flashbacks to actually doing that manually. So we ended up with unreliable builds and sort of defects sneaking their way into production last minute and hitting that canary city. So we knew we had to change this, and we had already started sort of taking critical parts out of these monolithic services and splitting them into microservices. So fast forward to today, and we've sort of fully embraced microservices at Uber. If you look at this image, a node in the image represents a service, and a line between two nodes represents a call path between two services. The size of the node represents how much traffic or how many requests that service is serving. So we split these monoliths into smaller services, and we gave full control over to the team that owned that service. And so now they're sort of able to deploy at any schedule they like or no schedule at all. They can do 40 deploys a day of that piece of the system. So our developers are extremely happy. The people that were actually doing manual deploys are extremely happy. Everyone feels good. This graph is nice and colorful, so this looks really great. Except what we noticed was we still had a number of reliability issues during our deployments. Around the same time as we were sort of fully embracing microservices, we were also moving to all active. So we began to serve trips in multiple zones. This was awesome. We lost a zone due to HVAC failure, and we rerouted traffic, and everyone was celebrating the work we had done. What we noticed still, though, was even though we were now all active, we still had this significant source of reliability problems. So in October 2015, we formed SRE at Uber. And one of the first things we did was start collecting deeper metrics about our incidents and outages. And so for every incident, we would track the time that it took us to detect the outage, the time that it took us to mitigate the outage, and the root cause type. So whether that was a code deployment, config change, lack of capacity. So we started really collecting these metrics. And when we did an analysis of sort of 6 months to 8 months of data, we realized that actually greater than 85% of our outages were caused by code deployments. So there's immediately a massive amount of low-hanging fruit that we need to sort of target here. So SRE realized that what we had done when we moved from monoliths to microservices is basically, given no guardrails. We'd provided no tools to sort of deploy reliably to production. And so I liken that to sort of, they were just kind of juggling hand grenades in our production environment. And here's Deadpool doing what Deadpool does. So a group of us got together in SRE, and we worked with our internal deployment team. So we have a team in Denmark that manages our deployment system. And we wanted to define a set of release principles that every critical microservice would go through in production. And this will sort of tie back to how we differ from Instagram and how quickly we push. So the sort of things that we knew we needed to have were we needed automated canary for every service. So we wanted every deploy of every critical microservice to deploy to 5% of production every single time. We wanted to not allow any deploy to go to more than one zone per region concurrently. So we're okay with having a zone in each region upgrading at the same time, but never more than one zone in a single region. And at the time, we had actually few zones. So a zone might be responsible for 200, 300 cities. So we wanted to see that every deploy sort of rolled out in these gradual stages. And the nice property of doing that is that you sort of, when you do have a degradation, you sort of see a step pattern. And it's really easy to reason about the outage. And then on top of that, we wanted every service to be rolled out to production in the same order, right? So what we see at Uber is we start a deploy of a service, and keep in mind there's so many services, it's difficult to know like which service is deploying at any time. We wanted to be able to say, hey, it looks like the first zone that everyone rolls out to is degraded. Lock that zone down and reroute traffic to another zone. So we wanted to always keep that ability. And then in addition to that, we wanted every developer to be able to easily specify, hey, roll back my deploy automatically on this subset of metrics. And if you think about Uber, we have both things like error rate, which is very simple to roll back on. We also have a core set of business metrics that you'd want to roll back on. So am I seeing unfulfilleds in a city? Are drivers suddenly going offline? There's a set of business metrics that might apply to a certain set of services. So we worked with the wonderful team in Denmark, and we sort of built these workflows, these that were SRE, defined by SRE. And we had this standard rollout policy, and this is a snapshot from the UI of probably the most critical service at Uber being deployed. And this sort of the green boxes are a stage of production being rolled out to, and you can see there's percentages assigned to those groups. So this was great, and we started onboarding a set of services, and we realized what happens when you've rolled out to all of production and you didn't detect the outage, and now you've got to move fast. So we added some additional workflows that you can sort of break glass. You can deploy in an emergency, you can roll out very quickly across zones. So we rolled this out to the sort of like the most critical, maybe 250 services at Uber, and we got some great results. So we had a lower time to mitigation for our incidents. because we were actually able to sort of detect, lock, and reroute traffic. So we kept our best mitigations and made those possible. We saw incidents reduced in scope. So where previously someone was able to just hit deploy and roll out to all of production at once without canarying, without all those guardrails that we put in place, now they were actually doing those things and reducing the number of cities or the number of users that were impacted. And then, incident reviews, whilst critical, are also really expensive, and we wanted to keep those for the very high scope outages. And so we saw less time spent. We usually get many developers in the room to sort of figure out how we let these high scope outages happen. And the chart is sort of just showing that a lot of the rollbacks were happening very early in the rollout process, so in the first stage of Zone 1. So those were sort of like that's the background to what we started doing. And there's a number of things that we sort of learned in the process, and I want to go through some of those and explain in a way like how we differ at Uber from something like Instagram. And the amazing thing about Instagram was they were able to deploy every 10 minutes. So they were able to do a full rollout to production. And I thought, how can we get there at Uber? So, one of the biggest learnings for us was that fast detection isn't always easy. And so, going back to what I mentioned earlier, detecting your error rate is something that is very straightforward. I can detect HTTP 500s, 400s, and roll back very easily. Now, at Uber, we're actually monitoring the health of a city, right? So are drivers actually going offline? Do the ETAs that we're seeing right now make sense? Are we surging at the right amount given the supply that's online and the number of people requesting a ride? And all of these things are changing based on what's going on in our cities. Is it a Giants game right now? Is there a special event that's going on anywhere in the city? So these things are actually not easy to detect. You need a little longer to actually pick up on them. And how quickly or slowly you roll out code will have an impact on the health of our cities if there's a defect. So this is one of the first things that we noticed, and this actually led us to saying that we don't think that we can deploy reliably in 10 minutes and maintain a good health of our cities. And so based on the fact that we knew we couldn't detect some of these city health metrics very fast, we knew we had to slow down a little. So the way that we've structured rollouts now is that we go to these, we go to Canary, we go to these larger and larger groups, and then we go to another zone. And so that required us to put some monitoring time in and slow down deploys from how they previously looked. And if you've ever tried to take something away from an engineer, engineers are never strong-minded. It's never hard to do that. It was at times extremely painful. We've got a bunch of really great engineers at Uber who very often do the right thing themselves, right? So a lot of them were manually doing something similar. But when you tell them, hey, we're going to automate this and it's going to go the same way for everyone, you face a little bit of sort of backlash. And nobody, the key thing I wanted to point out is that, nobody likes slowing down, including SRE. Nobody at Uber SRE wants to be the people that slow others down. And so one of the things we learned in this is that we made a big mistake. We should have, when we switched to microservices, built in the guardrails at that time. If we planned for reliability at the start, we would have actually saved ourselves a bunch of heartache, and we would have gone from really long deployments to now this takes an hour. Instead, what we did is really long deployments, and now we're down to 0. You can deploy like this to all of production, and now we're going to go back up. And making those sort of transitions is very difficult when you've got thousands of services and thousands of engineers. One of the things that made actually making the transition easier is when we started to build our policies for rollout based on metrics. So we've had a tough time at Uber always tracking the right time to detection, the right time to mitigation, and root causes of all of our outages. Once we started doing a better job of that, we could say that, hey, the rollout time is actually dependent on how fast you can do these things. Like, we can actually build a case for why it should take an hour or 45 minutes or an hour and a half for a certain service, because, hey, we can actually detect a surge outage in X amount of time. So therefore, you can move faster. So building policies driven by metrics is it's an easy thing to fight for, and engineers love data. If you present them with data, they'll actually react in a much better way. Ad hoc policies are horrible to defend or promote. And so we did this. We started actually collecting more and more of this data, and we presented a case, and we're using that to actually determine how fast we should move. And one of the things we did after the first 6 months is actually roll out faster than we had. And then another thing is the right amount of velocity to trade for reliability is a moving target. And for us, at Uber SRE, we believe that that moving target should always trend towards velocity. So we should, if we're doing our jobs, we should be improving how we detect outages. We should be improving our mitigation strategies, all our techniques for rerouting traffic. We should be making those faster. And as we make those faster, we can actually move our code into production faster. And so that's our goal. And we want engineers at Uber to also know that we are in favor of actually moving fast when we can do that safely. And then additionally, so one of the things we learned when we sort of reinforced failure domains in our code deployment strategies is that other systems sort of took note. Services that we build started to say, we should do the same things. We should roll out our changes to fewer cities. We should have an automated canary. So other systems around the company, and we have many systems that make changes, started to sort of take this on board. And now we're actually bringing people that are building change management systems around our company together and sort of defining these policies. So yeah, that's really all I had. Thank you very much for listening, and happy to take any questions.
Hi, could you comment on what tooling you use to actually get those better metrics to give you the data you needed to drive decisions?
Yeah, so we actually, at Uber, we have our own time series database. It's in-house. So we use that time series database, and we emit business metrics from all of our critical microservices. So that could be the number of people on trip, the number of drivers online, for example, at a per city basis. And so we store that in our time series database. And then we have another internal tool that we use to define alerts. And each of those alerts can trigger, if you choose, a rollback action in our deployment system. So that's how we've sort of wired it up.
Thanks for the talk. How do you guys capture time to detect and time to resolve for your incidents?
Yeah, so I would say it's not down to an exact science at Uber yet, but this is how we generally do it. So we go through, first of all, we report our incidents in a tool called Commander, and we track the incident history there. And then we do a postmortem for every incident that is of a certain scope. And at Uber, the highest scope outages are as soon as you impact all of a city and above. So more than one city and then a whole zone or greater. And for those incidents, we do a massive sort of deep dive in the postmortem, and we look at metrics to determine the actual time to detect is from the start of the incident to the first alert that we actually got from any system. The time to mitigate is obviously after we detected, how long before we saw those metrics improve because of an action that we took, or the system healed itself. Yeah, does that answer your question?
Yeah, thank you.
So at Uber, when you say deployment, do you mean just software deployment, or does it include configuration deployment? Is that managed differently? Do you have like rollbacks on those? If so, what kind of tools do you use and how do you manage it?
That's a really great question. So we actually have a few different configuration systems at Uber. One of them uses this exact same deployment system, and that is sort of like basic service config, and that that service follows the same policies. So it uses exactly the same rollout policies, but slightly faster. And we have several other configuration systems. So we have one which is a much more dynamic config, but it supports sort of our business entities, things like cities. So you can actually configure a city in a certain way. And after we were done with this project, we onboarded. We followed a similar process with that system. It's an in-house system because it's very Uber specific with like cities and our products configuration. But it has a similar functionality. We call it incremental rollout. So it will roll out to cities gradually and then to bigger zones.
So also if you're deploying to mobile clients, right, all the time, if you're doing configuration deployment to mobile clients, I guess it must be really hard to estimate what's going to break on what device. How do you know if something broke? How do you detect it on time and revert it?
So I should clarify that this talk is primarily focused on our backend services. Our mobile release policy is far more stringent, and that's primarily because of the rollout and rollback mechanisms for iOS and Android are not nearly as easy to sort of do, right? Rolling back an iOS build is not really a thing. So that process is much more stringent, and that is, a lot of that is based around feature flags and things of that nature. So for our backend services, we know that we can roll back, but I think the point of this talk to get across is that we know that, to your point, it's extremely difficult to determine what broke. Even if I know a certain service is down, I might not know the blast radius of that service in terms of which features that impacted. And the point that the thing that we realize is we need to not care. We need to be able to mitigate by getting really good at locking and rerouting traffic, and then we do root cause. And so that's sort of the big takeaway for us about how we roll out code, and that's why we think it's worth trading a little bit of our velocity for our availability. So roll out a little slower, give ourselves plenty of time to detect, and then implement these very simple mitigations before root causing.
Right. Thank you. That answers my question.
Thanks.
So, do you have any so how do your rollbacks work in terms of your progressive rollout policy? Like, do you have a policy of a rollback has, like, let's say you've rolled out to 70% of cities in the world, and then you need to do a rollback. Do you phase the rollback in the same way, or a rollback's always fast, or what's the?
Yeah, great question. So actually, the deployment team lets us manage our policies as basically YAML, and we can define a set of policies. So we actually have emergency rollout and emergency rollback available to the user. So if you do an emergency rollback, it's going to very quickly sort of revert the state of all those instances across production. And if you do a regular rollout, it's going to gradually sort of safely roll back. Yeah.
Hi. Could you just share the story about when you started using the auto deployment system? Because I'm kind of guess that at the time there might be a time that you had the auto deployment system and manual deployment system at the same time. So how did you start the auto deployment system?
Actually, we are using the same deployment system, but we had to make a bunch of changes to our services to sort of support onboarding to this new model. So when you're in this model where you don't have this in place, you tend to get a lot of snowflake setups. And so we had to make a number of changes to those cities to support the new model. Yeah. Thank you.